Kia ora tātou, it's Bill here. Hey, I want to introduce you to the operational amplifier. So let's have a look here. This is the first question in the assignment about the op-amp. So it's question 3. Okay, what do we got? We've got a symbol, which is, this is what you'd see inside a circuit diagram. You'd see this. This represents an operational amplifier or op-amp. Okay, this here is the model for it. You won't normally see this, but we're going to engage with the model so that you understand what's going on inside the op-amp. Well, in actual fact, we don't go inside the op-amp. Okay, but this is the model and this is the symbol, but what does a real op-amp actually look like? So let me just go over here, and what we've got on the desk here, I've got some integrated circuits. So here's some integrated circuits. Okay, here's an integrated circuit, and here's an integrated circuit, and there's one over here, a little bit hard to see. That's an integrated circuit, lots of little pins. These integrated circuits are what we call surface mount. So what you've got is got little tiny pins on them, which are soldered to the circuit board. Okay, these ones here, dip or through hole ones. Okay, they're actually for putting through the holes in the circuit board. So you can see it's got quite some long pins on it, which you can solder through circuit board. That's really convenient actually for putting inside a breadboard. So what I've got here, now these ICs, some of them are op-amps. So let's get rid of this one. There's no op-amps there, and this is not an op-amp, but this one here is an op-amp. And so what I've got here is a couple of different op-amps. I've got, for instance, an MCP6002, and I've got here an MCP6004. And the difference here is the fact that this IC has got 2 op-amps built into it, okay, and this one here has got 4. So if I want to look up those on the internet, I just let's go back to our screen, and I'll just look up MCP6004, and let me look at some images for that. And here's an MCP6004, and you can see that there are actually 4 op-amps here. If we go for the MCP6002, okay, what we've got we've got an MCP6002. Here's a good image. Let's look at this one. So this one here is the MCP6001, which is a 5-pin device, and it's actually got 1 op-amp inside it. And then this is the MCP6002. You can see it's got 2 op-amps inside it. And the MCP6004 has got 4 op-amps inside it. Each one of them has got this negative and positive inputs, which means the inverting and non-inverting, and it's got an output. And of course it's got a power supply. So if we go back to this, you'll see that what we've shown on the model here is I've shown the power supplies just to make sure that you understand that they do have a power supply, because you have to get energy into this device somehow, and it's got 2 inputs and an output. Of course, our MCP6004 has got 4 of these built into it, but only 2 power supply pins for the whole of the integrated circuit. Normally you would just engage with this in the circuit diagram, but really what you need to know is you need to know what it looks like inside in terms of its model. So this is what we call the equivalent model. You're familiar now with the equivalent circuit model in terms of something has some sort of input resistance and it's got some sort of output, which is usually and often described as having a source and an output resistance. What actually is inside this op-amp, the circuit diagram for it is quite complex. Let's just have a quick look. This is an 741, a really old op-amp. You can see there's loads of transistors inside this. Okay, but we never look at that. What we're really interested in is looking at this. What we're interested in looking at here is the equivalent circuit model, because this is how we can describe the behavior of an op-amp. And we only need to know about its behavior, not its internal functioning at this stage. We're not going to get into it that deep. So let's just go down and now have a look a bit at the behavior of an op-amp. So the first thing I want to have a look at here is we've got an op-amp. I've shown the power supply connections here, okay, just to be sure that you understand that there is power needed, because often in these simulations there will be no power supply pins, but it will still work. So what we've got here is we've got one of these inputs is connected to ground or 0 volts, and the other one has got this tiny little 70.4 microvolts on it. And what that means is on the output we've got 7 volts. And that is because this op-amp in the simulator has an amplification factor, or A. So an A means amplification factor, which is around about 100,000, okay? And that would be fairly well a minimum for an op-amp. So what happens here is I can hover over this and just rotate this here, and you can see that the output voltage is changing at the same time by that factor of 100,000. So I've got 74 microvolts going in, 7.4 volts going out. Of course, I can't put in 7 volts and get out of here 700,000 volts, okay? That ain't going to work. And the reason that doesn't work is because this thing here has a power supply limit of 9 volts, so it cannot go higher than 9 volts. So I've got 90 microvolts going in, I've got 9 volts coming out. What that means is that it's multiplying by 100,000. But actually, if I try and take this a bit higher, you'll see that the output ceases to change after the power supply voltage of 9 volts. So now I've got 104 microvolts in. I can't get 10.43 volts out because the power supply is limited to 9 volts. Okay, so what this does is it, within its range, it multiplies by 100,000 in this case. It could be higher. The other thing I want to look at here is I want to look at charge. Okay, now let's just look at charge flow. This charge flow, this charge is coming out the output and turning on this LED. Look at that. Okay, so the LED is on because what we've got is we've got some charge flowing through the LED. So there's some current here. Now, where's the current coming from? Because actually the inputs, there is no current. Okay, this is the thing about the op-amp. Okay, the op-amp input resistance, okay, is almost infinite, right? So what you've got here is you've got no current, but what it's doing is it's amplifying the voltage, okay? And so what we've got is the voltage is being amplified. But what does amplification mean? Well, basically what amplification means is when you add energy from the power supply to the input, okay? And so the charge here is actually, if you look at this really closely, you can see that there's some charge flowing from the positive 9 volts into the op-amp, going through its internal circuits and flowing out again. Okay, so that's where the current in the output is coming from. Okay, it's coming from the power supply. So that's just to give you a bit of a background on what this op-amp is. Okay, hope that's an interesting little useful tidbit of information for you, and you can get on and just do this assignment question without any difficulty. Cheers.